This thing right here is a transistor, the greatest invention of all time. In the Bionic 16 chip of an iPhone, there's over 16 billion transistors. Some flagship phones for Samsung also use the Snapdragon 8 Generation 2 chip, which is said to have over 16 billion. This is part 2 of my previous tutorial transistor video. Now, a transistor is basically a switch. But it is not a mechanical switch, it is an electronic switch, which means it has no moving parts. It can also be switched multiple times a second, which is impossible for a human being to do it mechanically. This unique characteristic of a transistor has made it popular to be used in applications like making electronics, radios, TVs, mobile phones, computers. Transistors are categorized into two: FET transistors and bipolar junction transistors. In my previous video, I talked about the NPN bipolar junction transistors. The only problem with these transistors is that they cannot handle heavy loads. I tried to power a 35 watts bulb using a 2N quadrat 2 transistor. I used a 100 kilo ohm resistor at the base. In my first attempt, there was no response, and the circuit was not drawing any power until I connected the base directly to 12 volts and the circuit bursted into flames. Now, in order to solve this problem, you can either use a Darlington transistor or a MOSFET. A Darlington transistor looks like a MOSFET in its physical appearance, but when you take a look at its inside connection, it consists of a pair of two NPN transistors. These two transistors are combined to make it stronger. For example, most Darlington transistors can handle a load of up to 100 watts. Transistors have very many applications in that they can be used to make projects, for example, oscillators and small signal amplifiers. I made this simple oscillator based on the resistor and transistor push-pull configuration. Here is the schematic in case you want to try out yourself. This circuit produces alternate square waves which can be used for several purposes. The most common amplifier which can be made from NPN transistor is the Class A amplifier. With this amplifier setup, two resistors are used to bias the base of the transistor. These resistors are R1 and R2. Another resistor limits the current that passes through the collector. It is RL. When you look closely, there is a resistor RE and a capacitor CE. This combination sorts AC signals to ground. By doing so, they prevent outputted signals from being interfered by the AC from the power supply. Another transistor type is called the PNP transistor. This transistor is slightly different from the NPN transistor. In scenarios where you want to put the load at the emitter, this transistor may be of help. Here I used a B1375 transistor. When you check this transistor's datasheet, you'll find out that this transistor was designed for audio outputs. You can also go further and make a Class AB amplifier. This combines a PNP and NPN transistor. Class AB amplifier is 25% more efficient than Class A amplifier. The lagging of the Class AB amplifier is also contributed by a notch at its output. As I told you earlier, bipolar junction transistors cannot handle heavy loads. In order to handle heavy loads properly, you can get yourself a MOSFET. Why a MOSFET? A MOSFET is more efficient than a bipolar junction transistor, and it's capable of handling heavy loads up to 49 amps for most MOSFETs, like this IRF Z44N MOSFET, which is a good substitute instead of an NPN transistor. But this is a subject for the next video. I hope you learned something new. If you found this video helpful, don't forget to like, share and subscribe.